Greetings and welcome, friends. Mr. Waddy and my real-life friends here today. We're talking about factoring x squared plus bx plus c. So that's kind of a standard form of a quadratic trinomial, three-termed expression. And today we're specifically, over the next few days, we're specifically going to talk about factoring these where the leading coefficient is 1. All right, so I'm not going to have, eventually we'll talk about, what if this was a 3x squared? But today, we're just going to say the leading coefficient is 1. And now factoring, remember, is when I write an expression as the product of its factors. So I'm rewriting it as multiplication. Right now, it's written as the sum of stuff. And so writing a polynomial as product of its factors is called factoring. To factor x squared plus bx plus c as two binomials being multiplied by each other, right? Two sets of parentheses. You could also think of this as unfoiling. All right, unfoiling is what we're doing. We're undistributing even. So if I want to have it multiply to this, you need to find the values of p and q such that p plus q, all right, so these two numbers are going to have to add to equal b. All right, add to equal b, and they have to multiply to equal c. All right, multiply to equal c. The reason that's true, check this out, in order to figure out how to unfoil, we foiled something. So x plus p times x plus q, if I multiply that out, let's just watch what happened here. I'll show you. So I would have multiplied the x by the x, and I got x squared. I would have multiplied the x times the q, and I would have gotten qx. I would have multiplied the p by the x, and I got px, and I would have multiplied the p times the q, and got pq. And now if I simplified this, don't worry, I'll bring it together in a little bit. This is the origins of factoring. You just have to know how to factor. So if I combine these like terms, I've got px's and qx's. Let's say, all right, track with me here. What if that was 3x plus 2x? What would that combine to be? 5x's, right? So px's plus qx's is the same idea as this. This 5, I want to point out, just comes from saying, oh, I did 3 plus 2, and then I multiplied that by x. Wait, don't worry, wait. Do you guys agree with this? 3x plus 2x. Wait, 3x plus 2x, is that the same as 3 plus 2 all times x? Which is 5x. I need 100% confirmation on this right here. One person saying 100% is not confirmation. All right, well, either way, we're moving on. So if I want to add px's and qx's, where p and q are just numbers, that's the same as writing p plus q times x. That's like this step right here. Okay, and so notice that if this is the same as x squared plus bx plus c, notice the things that are the same, that b is got to be p plus q, and c is got to be the same as, I'll do it this way, p times q. So if I'm trying to work backwards and unfoil something, I want to find the things that multiply to be my C term that also happen to add to be my B term. Okay? That's what I'm looking for. So this is the origins of it. You don't need to know the origin story. Actually, here, let me I'm going to hit some space button. There we go. There's some space bar buttons there. Like so. So here's the idea. Factoring x squared plus bx plus c when we have a positive c term. All right? And so I want to rewrite it like this, and I'm finding the values of p and q that add to b, and they also have to multiply to be c. All right? Here's we'll do some examples in a minute. This is my catchphrase right here. This is all you need to know. Find the factors of C that add to B. All right, and this word add is directly related to this plus sign. all right, or C being positive. So when C is positive, I'm going to find the factors of my C that add to B. All right, so I'll help you, my friends. Internet friends, just before this, we were toying around with some algebra tiles. It was pretty great. We were able to rearrange tiles into rectangles, which is really what factoring is all about. So here we go. All right, question. Is my C positive for this problem? What is C? C is the plus 16, right? And it's positive. So I'm going to find the factors of 16. So I'm going to make a list here, okay, guys? So ready? Let's make a list. What are the things that multiply to be 16? And watch this. Write this down. 1 and 16. And I try to do this systematically. So I start with 1. 1 goes in 16 times. Does 2 go into it? Yeah, you said, yeah, 2 times 8. Does 3 go into it? No. Does 4 go into it? 4 times what now? 4, yeah. Okay, so I find the factors of C. And are there any more? No, that would be 12. All right, and notice once I was going down my list, or up the numbers right there, and once I hit something that was 4, I don't have to keep going. Like, I don't have to try 4 again, or I don't have to try 6, or I don't have to try 8, because I already got 8, right? It kind of like the list wraps around on itself there. So I find the factors of C, and now I'm asking which of these will add to be 10. So 1 and 16, that would add to be 17, so that doesn't work. 2 and 8, that would add to be 10. Ding, 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 we found it. And 4 plus 4 would have added to be 8. So which of these factors added to be the B term? To find the factors of C, make a list, and which of those add to B. And when I factor it, it's going to be unfoiled, so it's going to be written as 2 things being multiplied. Because these are x's, my firsts are actually both going to be x's. And now I'm going to have 2 and 8 as being the numbers here. So 2 and 8. And so remember, I'll scroll up here a second. So 2 and 8 have to multiply to be C, and they have to add to be B. So 2 times 8 multiplying to be positive 16, they could both be positive, or they could both be negative, right? Because negative 2 times negative 8 would be positive 16. But which combination would give me an addition, a sum, to be positive 10? You think plus 2 and plus 8, does that add to be positive 10? Yes. So this is now factored. All right, I just spent a lot of time on one example. We're going to do a lot of these so your brain develops a pattern. Okay? Gonna be good. And we're doing this over a few days here. So factoring. Here we go. Wait, slow down. We're doing this together. All right, first question. Is the C term positive? Yes. So I'm going to find the factors of C. So numbers that multiply to be 6. 1, 6, 2, and 3, 3, and oh, I already got 3, so my list is done. And now I'm asking which of these will add to be 7? Which pair? Yeah, the 1 and 6 add to be 7, 2 and 3 add to be 6. So 1 and 6 are the winners today. So I'm going to have, in my sets of parentheses, I'm going to have an x with a 1 and an x with a 6. And now I've just got to figure out the signs in the middle. Now they multiply to be positive, so their signs are the same. It's either plus plus or minus minus. But they have to add to be 7. So would negative 1 and negative 6 add to be 7? No. So I think plus plus is the only combination that works there. And this is now the factored form of this polynomial. Let me just do a quick check. All right, check it. Does x plus 1 times x plus 6 really equal that? Really? Really? Let's find out. X times x is x squared, right? X times 6 is 6x. 1 times x is 1x, or just x. And 1 times 6 is 6. And then if I was to combine the like terms of 6x plus 1x, notice I do in fact get x squared plus 7x plus 6. And that is what I started with. So it worked out. All right? So cha-ching, we found the factored form. We found it. Let's see if you guys can try part 2 here. All right, monitoring progress, question 2. Find the factors of 8 that add to be 9, and I'll be around to check on you. Factors. Now you're going to add factors. Let's catch up our internet friends. So when I say find the factors of C, I'm finding the numbers that multiply to be 8. So 1 goes into 8 8 times, 2 goes into 8 4 times, 3 does not go into 8, and 4 I already got. So of this list, now I'm trying to figure out which of these factors add to be 9. 1 and 8 add to 9. Where 2 and 4 would have added to be 6. So if this was a 6 here, then these would have been my answers, but it isn't. All right, so my answer is x. Yep. Yeah, so x plus 1 and x plus 8, right? These are the numbers that are going there. El más bien del mundo. Okay? All right. Let's look at example 2. I think I can make it that far today. Yes. We're just going to do positive C's today. So, example 2, same idea. My C term is positive. All right, C term is positive. So I'm going to find the factors of 12. So 1 goes into 12 12 times. 2 goes into 12 6 times. 3 goes into 12 4 times. And 4 I've already got. All right, that wasn't the best song, but it worked. So I want the factors of 12, here they are, that add to be 8. Now this is going to add to be a negative 8. I'm going to worry about the sign at the end. Some mathematicians, they jump right in and start thinking about all these combinations. Right now, I just say worry about the 8, and I'll show you when to worry about the sign. So let's see, 1 plus 12, that's 13. That is not going to be 8. 2 and 6, that's going to add to be 8. And 3 and 4 would have added to be 7. So this is the combination that I wanted, right? So I'm going to have, now check this out, don't write your signs yet. I'm going to have an x with a 2 and an x with a 6. Now, these have to multiply to be a positive 12. That means that their signs are either plus plus or minus minus, because a negative times a negative is a positive. And so these are going to have the same sign. And now I've got to ask, what would add to be negative 8? Would positive 2 and positive 6 add to be a negative 8? No. However, a negative 2 and a negative 6 would work out. Okay, so I don't do the signs until the very end, and that actually saves me half of the guessing and checking that other people often do. All right, so I think about that at the very end. I say, okay, their signs are the same because they multiply to be positive, but if they add to be negative, negative, negative would be the only combination. So let's see. I think I've got a couple more monitoring progress ones that I could do. Yeah, perfect. Perfect. Let's try monitoring progress 3 and 4. You might have to flip the page or go to the next one maybe. I might not have, I don't think I lined these up the best. So let's see. Find the factors of 3. 1 and 3. All right. So 1 and 3. So look for, it might be after. Yeah, you saw it. You see it there. Yep. 3 and 4. See if it matches these ones with a W. We skipped example 3, I think. Or we skipped a little chart. Yeah. So here we go. Find the factors of the C term. I got them. There's only 2. And I'm looking for the ones that add to be 4. So I'm going to have 1 and 3. Oh, wait. Do 1 and 3 add to be 4? Yeah. And if they didn't, then I actually would be done. I would just say not factorable. And that does happen. We did. Yeah, I'm going to rearrange it for future generations. But right now, this is what we got. Now check this out. Can I do this? No, that's not going to work. Yeah, I got to do W's there. What? Represent Waddy math. All right, here we go. So dub. And it's going to be a W with a 1 and a W with a 3. And now the 1 and the 3 have to multiply to be positive, so their signs are the same. It's either plus plus or minus minus, and they have to add to be negative. So which combination would add to be a negative 4? No, can't be a plus or minus. They're the same signs. Both are negative. Well done. All right, because 2 negatives will multiply to be a positive, and 2 negatives will add to be a negative. So you just kind of do a little bit of guess and check on the signs sometimes, and that's fine. That's fine. Let's see, monitoring progress question 4. Factors of 35. Yikes, okay. So 1 and 35. Does 2 go into it? No. 3? No. 4? No. 5? Yes, 5 goes into it 7 times. And so now I want the ones of these that add to be 12. I'll figure out the sign later. So 1 and 35, that adds to be 36. Yikes. And 5 and 7, that adds to be 12. Aha! That's what I wanted. So I'm going to have a n with a 5 times an n with a 7. Now, because these multiply to be positive, their signs are the same, so it's either plus plus or minus minus, and you're saying, Brandon, that these are going to be minus minus because they have to add to be negative, and I agree. All right, let's have you guys try one last problem. Let's have you guys do monitoring progress question 5. I'll put this up on the screen so our internet friends can play along at home. Or during study hall. All right. Ooh, this is a lot of factors. Factors of that list. Some people are like, things that have 20 and like writing your possibility, like that you might be like missing. That's why I like writing my factors. Eventually, you guys will be able to algebra 1. See if you guys can figure out the signs. Well. Alright. So, internet friends, Mr. Waddy here. Have you ever had a hard time finding the factors of 24? I'm going to help you out. First, I start with the smallest positive number that is an integer, such as 1, and 1 fits into 24 24 times. Then I go to the next largest integer, like 2, and 2 goes in 12 times. Does 3 fit? You bet it does, 8 times. And does 4 work? Yes, sir, 6 times. Does 5? No, and I don't have to try 6 because I've already got it. So Class A, which of these added to be 14? 2 and 12 add to be 14. And as far as my combination, I'm going to have an x with a 2, an x with a 12. What about their signs? Because they multiply to be positive, so their signs are the same. And they add to be negative, so negative, negative. Well done, friends. Thank you for watching, and have a great day.